Hello everyone, this is part 2 of chapter 1 revision.
Don't forget to pause the video, try to solve them, and check your answers with us later. Okay, let's start with the first one. 46 to the power 0. Any number raised to the power 0 equals to 1. Any number or any variable raised to the power 0, the answer is 1. Okay, write each expression using a positive exponent. If we have a negative, negative here means the reciprocal. Okay, so this is, if we want to write it using positive, it will be 1 over 8 to the 4th power, the reciprocal. Okay, here also, if you wanna get rid of the negative, find the reciprocal. It will be 1 over y to the power 9. And here we have to write using negative exponent. If we want to add the negative, it means that the reciprocal. So this will be d to the power minus 6. And here do the reciprocal, then add the minus sign. Now let's go for question number 7. In case of multiplication and the bases are similar, we're going to add the exponent. Add 4 plus minus 6, this is minus 2. So we can have 9 raised to the power minus 2. And to get rid of the negative in the exponent, do the reciprocal. It will be 1 over 9 squared. Here also the same, we have same base. We're going to add the exponent, negative 9 plus 3. This is y equal to negative 6. And this is equal to 1 over y to the 6th power. Question number 9, we have a division. In case of division, if the bases are similar, subtract the exponent. We're going to subtract x. It will be negative 8 minus 12. Minus, it's positive, so this is equal to x to the power negative 8 plus 12. This is equal also 12 minus 8 is 4, so this is x raised to the 4th power. Question number 10, the same. We're going to subtract the exponent. It will be d raised to the power negative 13 minus 2. Minus, this is positive. So it will be negative 13 plus 2. This is equal to negative 11. D raised to the power of negative 11. And to get rid of the negative, you can write it as 1 over d raised to the 11th power. Okay. Now let's go to question number 11. Here let's start with the similar bases. 8 with 8, negative 7 plus 7, this is equal to 0. So 8 raised to the power 0 is 1, not a 0. This is equal to 1. And here also we have similar bases. We're going to add the exponent. 4 plus minus 4 equal to 0. 10 raised to the power 0 equal to 1. Okay, so this is equal to 1. 1 times 1 equals 1. Select all of the expressions that are simplified. Let's start with the first one. N raised to the 4th power. We can simplify it. This is written in the simplest form. 1 over 9 to the power of minus 5. This can be simplified because we can write it as n to the power of 5. It's not written in the simplest form. Also here, not written in the simplest form, bases are similar, we can add the exponent. Not written in the simplest form. This one written in the simplest form. Okay, now pause the video, try to solve them, and then check your answers with us. Okay, let's go for the first question. 1.6 times 10 to the power 3. This is the scientific notation form. We're going to convert it to the standard form. Remember, if we are multiplying power of 10 and the exponent here is positive, we're going to move the decimal point to the right 3 steps. So the number, it will be bigger. The 1.6 now, it will get bigger after multiplying with 10 to the power 3, which is 1000. So we're going to move the decimal point 3 steps to the right. It will be here. And the empty spaces, we're going to add zeros. Okay. So the answer will be 1600. For question number 2, we have 1.49 times 10 to the power negative 7. Here we have a negative exponent. If we have a negative exponent, it means that this number will get smaller. We're going to move the decimal point to the left 7 steps. We're going to move it to the left 7 steps. We are going to move it, this is 1 step, and then the rest we have 6. We're going to add 6 zeros left, okay? So we're going to have 0.6 zeros, 1, 2, 3, 4, 5, 6. Now we're going to write 149. Okay, one more time. Here is the exponent is negative, so we're going to move the decimal point to the left. The number will get smaller. We moved it 1 step, and we have 6 left. So we added 6 zeros. Okay, let's go for question number 3. A calculator screen shows a number in scientific notation as 8.3e minus 6. This means 8.3 times 10 to the power minus 6. Write this number in the standard form. Okay, now it's written in the scientific notation. Let's write it in the standard form. Here first we're going to move the decimal point to the left since the exponent is negative. If it's negative, we're going to move it to the left. The number will get smaller. 8.3, 1 step, it will be here, the decimal point. Then subtract 1, we're going to have 5 left. So we're going to have 5 zeros, 0.1, 2, 3, 4, 5, then 8, 3. Here is the same, but with positive power of 10. We're going to write it in the standard form. We have power 11. We're going to have 11 zeros. 7, then 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 0, 3, 3, Okay, now rewrite using the scientific notation. Remember that in the scientific notation, we should have only 1 digit in the whole part and non-zero digit in the whole part. And the rest, it will be in the decimal part. So we're going to move the decimal point from here to here. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 steps to the left. So it will be 2.204 times 10 to the power, I forgot, 369, to the power of 9. The next one. Here also we're going to move the decimal point, so we're going to have only 1 digit and a non-zero digit in the whole part. So we're going to move the decimal point here. We're going to move it to the right. So we can have a negative exponent. 1, 2, 3, 4, 5, 6, 7, 8 digit to the left. So it will be 6.42 times 10 to the power negative 8. Now let's go for question number 7. It says a common race is 5K race where runners travel 5 kilometers. Is it more appropriate to report the distance as 5 kilometers or 5 times 10 to the power 6 millimeters? Explain your reasoning. It's more appropriate to use 5 kilometers because here we have the big distance. We're going to use a bigger unit, okay? Big distance with big units. And we're not going to use millimeters. We use the millimeters for small measurement, okay? So we're going to say 5K or 5 kilometers is more appropriate because it's better to use big units with big measurements or big numbers. Now let's go for question number 8. The population of Florida was recently recorded as 20,612,439 people. Write an estimation in scientific notation for the population. Okay, so first we need to estimate this number. You can round it to 21 million, or you can round it to 20 million, also acceptable, or you can round it to 20,600,000. All of these numbers are acceptable. I'm gonna estimate it to 20,600,000. Someone else can round it to 21 million, also it's acceptable. And then we're gonna write it using the scientific notation. It will be, we're gonna move the decimal point here. We're gonna move it 3, 6, 7 steps to the left, so it will be 2.06 times 10 to the power of 7. Okay, someone else can round this number to 21 million, for example. And if we want to write it using the scientific notation form, we're gonna move the decimal point till we have one digit in the whole part, one non-zero digit. It will be 2.1 times 10 to the power 7. Both are acceptable. Okay, question number 9. The diameter of a grain of sand is 0.0024 inch. Write an estimation in scientific notation form. Okay, so first we have to estimate the number. We're gonna round it to 0. This is approximately 0.002. If we wanna write it using the scientific notation form, it will be 2 times 10. We're gonna move the decimal point 1, 2, 3 steps. So it will be 10 to the power minus 3. Okay, let's go for question number 10. The mass of planet Earth is about 5.98 times 10 to the power 24 kilograms. When this number is written in the standard notation, how many zeros are in the number? Okay, so if we want to convert this number to the standard form, move the decimal point 24 steps to the right. First, we're going to move it 2 digits, and then we're going to add zeros. First, we're going to move it 2 steps to the right till the decimal point here, then we're going to add the zeros. So we're going to subtract from the exponent 2, it will be 22. Okay, so the number in the scientific notation, in the standard notation, it will be 598. Then we're going to have 22 zeros. Okay, so the answer, how many zeros? The answer is 22 zeros. Okay, now let's go for question number 1. Don't forget to pause the video and try to solve the questions by yourself first. Okay. Here in question number 1, it says that there are about 3 times 10 to the power 11 stars in our galaxy, and about 100 billion galaxies. So in one galaxy, we have 3 times 10 to the power 11 stars. Okay, this is only in one galaxy. If we have 100 billion galaxies in our observable universe, suppose every galaxy has as many stars as ours. How many stars are in the observable universe? Write in the scientific notation. Okay, so one more time. This is the number of stars in one galaxy, 3 times 10 to the power of 11. And this is in one galaxy, and we have 100 billion galaxies. So we're going to multiply to find the total number of stars. The total number of stars equal 3 times 10 to the power 11 times the number. This is for one galaxy. We're going to multiply it by the number of galaxies. We have 100 billion. If billion is 10 to the power 9, the million 10 to the power 6, billion 10 to the power 9, trillion 10 to the power 12. So 100 billion, it's 10 to the power 9. Okay, simplify now. 3 times 1 is 3. And here we have 2 zeros. We're going to add them to the 9. Okay, let me simplify it more for you. Let me first write this in the correct scientific notation form, it will be 1 times 10 to the power 11, because we should have only one digit in the whole part, not 2 or 3, times 3 times 10 to the power of 11. Now we can simplify. 3 times 1 is 3. Bases are similar. Here, as you can see, 10 to the power 11, and here we have also 10. Since the bases are similar, we're going to add the exponent. 11 plus 11 is 22. Question number 2. Humpback whales are known to weigh as much as 80,000 pounds. The tiny krill they eat weight only 2.1875 times 10 to the power negative 3 pound. About how many times greater? How many times greater? It means that we're going to divide the weight of the whale divided by the weight of the krill they eat, which is 2.1875. But we are lucky because they said about how many. About means that we're gonna find the estimated value, okay? So about, we're gonna first round this number. I'm gonna round this is times 10 to the power of negative 3, okay? So I'm gonna just write it 2 times 10 to the power minus 3, because this is a very small number, okay? And the 80,000, we're gonna write it as 8 times 10 to the power of 4. 4 zeros, 1, 2, 3, 4, so it's 10 to the power 4. Now we can simplify. 8 divided by 2 is 4. Same basis, we're gonna subtract, but here pay attention. It's 10 to the power 4 minus 3, so it will be positive, okay? This is equal to 4 times 10. This will be positive. 4 plus 3 is 7. 4 times 10 to the power 7 times greater. Let's go for question number 3. Evaluate and then express your result in the scientific notation form. Here, as you can see, we have to add, but first you have to check the power of 10, if we have the same exponent or not. So we can add the same digit with the same place value. We can't add numbers with different place values. We have to order the numbers correctly, so we can add the ones with the ones, tens with the tens, and so on. So first we have to convert one of them to make it like the other one. Here we have 10 to the power 3. We can make it 10 to the power 5 if we move the decimal point 2 steps to the left. So this is equal to 0 point. We're gonna move it 2 steps to make it 5. Okay, this is 1 and here is 2, and the empty space will be 0. So this is 0.0113 times 10 to the power 5 plus 1.28 times 10 to the power 5. Now the exponents or the power of 10 are the same. We can add. Remember, when we add decimals is to order the numbers correctly. We have 1.28 plus 0, put the decimal point in the top of the other decimal point, 0, 1, 1, 3. Empty spaces, put zeros. 0 plus 3 is 3, 0 plus 1 is 1, 8 plus 1 is 9, 2 plus 0 is 2, put the decimal point down, 1 plus 0 is 1. And we're going to have the same power of 10. So the answer for this is 1.2913 times 10 to the power of 5. Let's go for question number 4. Also here we're going to subtract, but unfortunately we have different exponent or different power of 10. We have to convert one of them to make it like the other, and then we can subtract or add. Okay, I'm going to make this 4, 6, but in the other hand, we're gonna move the decimal point 2 steps to the left. 1, 2. The decimal point will be here. The empty space will be 0. So this number, after converting the power of 10 to 6, it will be 0.013 times 10 to the power 6 minus 7.26 times 10 to the power of 6. 7.26 minus, order them correctly, put the decimal point down the decimal point. Here we have a 0, 0, 1, 3. Empty space, put 0. Now let's subtract. 0 minus 3, we can do that. We're going to borrow. 10 minus 3 is 7. 5 minus 1 is 4. 2 minus 0 is 2. 7 minus 0 is 7. So the answer for this is 7.247 times 10 to the power of 6. Okay, now let's go for question number 5. It says that the speed of light is about 1.86 times 10 to the power 5 miles per second. The star series is about 5.062 times 10 to the power 13 miles from the Earth. About how many seconds does it take the light to travel from Sirius to Earth? Write in scientific notation around to the nearest hundredth. Okay, so first you have to know that the question said about. About, it means that we don't want the exact value. You can round or estimate the numbers. So the speed of light, we're gonna estimate it. I'm gonna round it to 2. 1.86, we're gonna round it to 2 times 10 to the power of 5 mile per second. This is the speed of light. So this is approximately. And the distance from the Sirius stars to the Earth, also I'm gonna round it to 5 times 10 to the power of 30. After that, the question asks us about how many seconds does it take. To find how many seconds does it take, we're gonna divide the distance by the speed of light. So the distance is 5 times 10 to the power 13 divided by the speed of light, which is 2 times 10 to the power of 5. 5 divided by 2, this is 2.5 times 10 to the power 13 minus 5 is 8. Okay, now let's go for question number 6. The table shows the amount of money raised by each region. The 4 regions raised a total of 5.38 times 10 to the power 4. How much did the West raise? Okay, this is unknown. But what we know that the sum for all of these is 5.38 times 10 to the power of 4. So what we can do, we're gonna add these numbers together and then we're gonna subtract them from the total. So to add them all have the same exponent except of this one. We're gonna convert it to 4. We can make this 4 by moving the decimal point 1 step to the left. So it will be 0.675 times 10 to the power 4. Now we're gonna add them and then we're gonna subtract them from the total. Okay, let me rewrite them here. We can have 1.46, 2.38, 0.675. Okay, empty space, put zeros, add. We're gonna have 5. 6 plus 8 is 14. 14 plus 7 is 21. 1 down, 2 up. 4 plus 2 is 6. 6 plus 6, 12. 12 plus 3, 15. 5 down, 1 up. 2 plus 2 is 4. And don't forget to bring down the decimal point. And this multiplied by 10 to the power of 4. Now we're going to go for the total and subtract this number from the total. The total is 5.38 minus 4.515. Put 0 in the empty space, subtract 0 minus 5, we can do that. This is 7, and here is 10. 10 minus 5 is 5. 7 minus 1 is 6. 3 minus 5, we can do that. We're going to borrow. 13 minus 5 is 8. Bring down the decimal point. 4 minus 4 is 0. So the west times 10 to the power of 4, okay? But wait, we should write the answer in the scientific notation form. And we know that in the scientific notation, we should have a non-zero whole digit, okay? So we have to move the decimal point one step to the right. To do that, we're going to subtract 1 from the exponent. It will be to the power 3. So the final answer will be 8.65 times 10 to the power of 3. This is the amount of money raised by the West region. That's it for the first video. We finished the first unit. In the next video, we're going to do the same for unit 2. Thanks for watching. Don't forget to like and subscribe.